Okay, good afternoon. So what we're going to do, I'm going to go with that practice quiz first. Okay, if you get time, then we talk about the partial derivatives, but that is not going to be covered on this quiz. Okay, so the quiz would cover only two sections. Okay, that would be section 13.1 and 13.2. Function of several variables. Okay, the domain, the range, the graph, the limit, and the continuity. Okay, so this is the one that I'm going to explain. The one that we posted. Okay, practice quiz number 2. As you can see, the concepts are going to be just the definition of a function. Okay, domain, range. We give you one question on this one. Then we are going to have some standard limits. Okay, the first group is standard one. The second one is the one that you have to prove it. And the last one is when the limit of the function does not exist. And then the question of the continuity. Okay, one question, two different functions. Okay, let's do it. And if you get time, you go with the, just a partial derivative as well. So this is going to be practice quiz. So the assignment that will be collected is going to be up to the end of this section. Okay, the section 13.1 and 13.2, and the numbers, as usual, I will post some numbers for you. So this is going to be the case. Okay, practice. Okay, practice quiz. Number 2. So the first topic is going to be a function of several variables. Okay, the first one. A function is given to you. So this is your function, f of x, comma y, equal to the square root of 9 minus x squared minus 4y squared. It's a function of two variables, okay? Two variables, they ask the first part, they ask for the evaluation of the function. So part one, you want to evaluate. Okay, you want to evaluate f of 1. So you go to the function and you replace x by 1, y by 1, okay? And if you get the chance, you simplify it. So this is it, f of 1 is going to be equal to the square root of. You substitute, it's going to be 9 minus 1 squared, which is 1, minus 4 times 1 again. So that gives you radical 9 minus 5. Okay. So which is going to be, in this case, is a radical 4. And radical 4 is equal to 2. So f of 1 is equal to, is equal to 2. And then you are there. Okay, just select the ordinary function. You want to evaluate it, so we get to it. That is part 1. Any question? Part 2, finding the domain and the range. Okay, part 2, we'd like to find the domain. Okay, find the domain and range of the function. Okay, the range of the function f. Domain is going to be like, check to see the operation that the function are going to perform. Is there going to be any restriction on this operation? You see the function is a square root function because these are numbers. The function is a square root function, and for case of the square root, you must guarantee that the inside is never negative. So this is how we are going to define for the domain, or define the domain. That's it. Say that f is defined. Okay, f is going to be defined when that expression inside 9 minus x squared minus 4y squared is always greater than or equal to 0. That's it. You have to write it down in set notation, okay? So remember, your function is a function of two variables. So your domain is going to be a subset of, R2. You can move this to the other side to get a clear idea of the shape of the domain. You don't have to, but so this would be x squared plus 4y squared less than or equal to the 9. And you know that this is going to be an ellipse. Okay, you can divide it by 9 if you like to create it, but the domain is going to be a collection of points, okay, x comma y, that satisfying this condition, which is going to be x squared plus 4y squared less than equal to the 9. So this is going to be your domain. Okay, so you have to write down in set notation, okay, identify the position of the domain. So that's done. Okay, if you like the domain, this is optional. It's going to be the points, okay, on, in, and inside, and else. So as soon as you give us this domain set notation, we are going to be happy. So that would be the domain of the, okay, the domain of the function. Any question? Now the range. Range is the output. Output of the function is going to be numbers. Okay, so you're going to call the function z to find out if you can find any restriction on those numbers. So for the range, this is the way we're going to do it. Say that the notes that if you are going to call the output z is equal to the f of x comma y, which is your function. Okay, 9 minus x squared minus 4y squared, then get the restriction. The restriction is z is never negative, so z is greater than or equal to the 0. Okay, and check to see if you can find any other restriction. If you follow the negative sign here, that gives you something nice. So z is equal to, this is going to be 9 minus, you get the x squared plus 4y squared. You see that x squared plus y squared is a positive number. So you're taking out something out of the 9. So the result is going to be less than 9. So this is going to be less than equal to, okay, the inside of the radical would be less than equal to the 9. Since you have the radical, this is going to be less than equal to the square root of 9. Okay, so this is 9, 9. 9, 9 is a 9 minus something. So when you take out something out of the 9, so the result is going to be less than 9, which is equal to 3. So you have the restriction for the values. So z is going to be between 0, 0, and 3. 0 and 3. So that gives you the range of the function. You have to write down an interval notation. So the range of this function is going to be closed interval of 0 and 3. So that gives you the range of the function. Any question? Since the range is, you know, that the range is going to be just a set of numbers. So the set of numbers are going to be on the number line. So in this case, the domain is a closed interval of 0 and 3. Okay, so that would be the domain of the function. So what else? We want to know what's going to be the graph of the function. Okay, so part C of the same problem. The part C, they ask for the identify the graph of the function. Identify, okay, the graph of this function. The graph of f. We know that the graph is a collection of points that satisfy the, you know, your equation. So the graph of the function is going to be, you see, you set it equal to the z again. And so you say that if z again is equal to the f of x comma y, and is going to be your function values, output 9 minus x squared minus 4y squared. Remember the graph is a collection of points that satisfy this condition. So in this case, the points are going to be x, y, and z, all of them together. So the graph is going to be this one. So the graph of f is going to be a collection of points. You have to have the graph as a three-dimensional solid. Okay, so it's going to be a collection of x, y, z. That's satisfying this condition. The condition is z equal to the Okay, z equal to the 9 minus x squared minus 4y squared. Okay, so that gives you the graph of the graph of the function. Now we can describe it for us. Okay. So if you want to describe it, we did it before. You see, this is a z, which is a 9 minus x squared minus 4y squared. You can square it, that gives z squared. And this is going to be 9 minus x squared minus 4y squared. If you put into one side, that gives you x squared plus 4y squared plus z squared equal to the 9. And since you take the square root, z must be greater than or equal to the 0. Now, if you look at this equation, okay, the graph of this equation, if you like, x squared plus y squared plus z squared to the 9, you know that this is one of those quadratic surfaces, okay? And this is the extension of the ellipse in three-dimensional. You know that if you move up an ellipse in three-dimensional, the result, we call it ellipsoid, okay? Ellipsoid or egg-shaped, okay? So that's it. But since z is bigger than or equal to the 0, you are going to have only upper part of the ellipsoid, okay? It's like in the case of the circle, you go, you know, with the, in case of the sphere, you go with the hemisphere. You say half. So it's going to be the same thing. So the graph is going to, because they ask you to identify it. So you have to tell us what it is. So this is going to be the final answer, that the graph, okay, the graph of f is the upper part, of an ellipsoid, of an, okay, ellipsoid, egg shape, if you like, to get the result. Okay, since you take the square root, remember, it's not going to be a full ellipsoid. It's going to be just one portion, half. So this is going to be the result. Any question? So this is how we check one of the sections. You see section 13.1. They describe the function of several variables, evaluation of that function, the domain of the function, range of the function, and the graph of the function. So we give one question, and this is the way we are going to check. Okay, that's the topic number 1 of those 6 topics that we're going to be interested in. Okay, already. So that was the question number 1 on this. Okay, that is question number 1. Question number 2, we are going to check some limits. And the first group are ordinary function. Remember, we can use all sorts of equation, all sorts of property, theorems of the limits, like in calculus 1, okay, the sum of the limits, the product of the limits, formula, okay, and the fact that if you want to find the limit of the polynomial, which is the exact value. So the first group, there is nothing to be special, okay, only one case, but otherwise it's straightforward, okay? So this would be, oh, I'm sorry, we have another one. You can check this one quickly. Look at this, I missed it. Number 2, you have this function, find the domain and the range. So let's do this one too, because this is going to be used for the continuity, especially the domain. Some people, they miss it, then they want to write it down. So we go with the question number 2 first, then we go to the domain, okay? So let's see what the question number 2 is. So question number 2, you want to find the domain and the range of this function. Okay, find the domain. That's the domain and range. Range of this function. You have a function of 2 variables, f of x comma y, and this is 1 over the square root of 4 minus x squared minus y squared. Not difficult, but we want to know how you write it down. Again, it's a rational function, and the denominator is a square root function. So we have 2 restrictions. For the rational function, denominator cannot be 0. For the square root function, the inside cannot be negative. So the domain would be where the inside, because even the square root, we usually say this is greater than or equal to the 0. But since you cannot have the 0, the condition is going to be only 4 minus x squared minus y squared must be strictly bigger than 0, okay? So this is how we get the solution. Okay, so we declare that f is defined. F is going to be defined when or where this expression 4 minus x squared minus y squared is strictly bigger than 0. Not bigger than or equal to, just greater than 0. Which is the same as x squared plus y squared. Okay, to be less than. Now it's easy to describe because x squared plus y squared equal to 4 is a circle. In this case, that give you, okay, that would give you just the point inside the circle. So the domain is going to be, the domain is going to be a collection of points, x, comma, y, satisfying this condition. Condition is that x squared plus y squared must be less than 4. Okay, that's it. That's the domain. Now it's going to be the point inside the set. So it's going to be the point. Again, you describe it as a collection, as a set. We accept it. Okay, it's going to be the points inside the circle. Inside the circle with radius 2. With radius. So that gives you the domain of the function. Any question? So the restriction are going to be just, if you take the square root, if you get a rational function, this is where we put those restrictions. That is the domain. Range. Range, the output is a real valued function, so the range is going to be a collection of numbers. Let's see if we can put some restriction on it. Okay, so for the range, this is it. We are going to set note that if you call it z to get the restriction, if z is equal to 1 over, okay, 4 minus x squared minus y squared, then quickly you will find out that the z is positive, it's never 0. Okay, so we are going to have a positive number. So we check to see if you have any other restriction. The other restriction is, again, you work on this one. Okay, like the one that we did also. We got this expression inside the radical. So you have 4 minus x squared minus y squared. So it's going to be the square root of 4. Pull out the negative sign. So that gives you x squared plus y squared. Again, you see that's a radical 4, or inside the radical is 4, 4 minus. When it's a 4 minus, this means this is going to be less than 4. 4 minus. Okay, less than 4, but since it's a square root, it's going to be less than, okay, this is it. So that expression would be, okay, that expression is going to be less than radical 4, okay, in this case. And this combination can also be 0, nothing to worry about. So this is going to be, let's say, less than or equal to the radical 4, which is equal to 2. Okay. So that give you the result. But the one you are interested in is the reciprocal. So if you take the reciprocal on both sides of the inequality, so you reverse the sign of the inequality. So this means 1 over the square root of 4 minus x squared minus y squared would be what? Would be greater than or equal to the 1/2. And you take the reciprocal, you have to reverse the sign of the inequalities. Okay, and this is your z. Remember, that was z. So this basically means your z is going to be greater than or equal to the 1/2. Okay, remember the range of the function is a number. Is the that number is called, we call it z, and in this case, z should be greater than or equal to the 1/2. In interval notation, you know that greater than or equal to the 1/2 means 1/2 up. 1/2 up means gross interval of 1/2 and the positive infinity. So the range of your function, you see the range. The range of this function is going to be the gross interval of 1/2 and the positive infinity. So that gives you the range of the function. Yeah, I just wanted to see it because you know it's a fraction to see how we're going to operate. Any question? Yes.
Why is it greater than or equal to? Isn't it just greater than the 1/2? Or let,
You see, it's okay because your x squared plus y squared, x and y can be 0.
okay,
You know, if both of them can be 0, down the denominator, there is no harm.
okay,
See,
yes.
the sum cannot be equal to 4. If it's going to be equal to the 4, then it would be 0.
Okay, but because
See,
it's
that's
1/2.
why, yeah.
Got it. Thank you.
Okay, it's a 4 minus something is less than or equal to 4 because that's something maybe 0.
Okay.
Okay, so the range is going to be gross interval of 1/2 and positive infinity. Okay, so pay attention. This is going to be one question we are going to be considering. So the first one was a little bit more general, okay, because we just checking the value, the domain, the range, the graph, and this is just a short one. So this is topic number 1. Definition of a function, okay, evaluation of the function of several variables, domain, range, and identifying the graph. We give you one question on this. Okay, any question? Now going to the limit, the first group. For the first group, it's standard, nothing to worry about. The functions are nicely can be done. Okay, so that would be our question number 3 now. This is the first group. You want to take the limit, you see, you can use all sorts of, it's going to be direct substitution because all these functions are nice, like in calculus 1, and nothing to worry about, okay? So this is the first group of the limits. So this is it. So that would be number 3. You want to find the limit, of course, if it exists. Okay, find the limit. Find the limit if it exists. Okay, let's listed a couple of usual practice one. The first one is a kind of a polynomial. So the limit of x comma y goes to 5 and -2. And the function is this one, x to the 5th, 4x cubed y minus 5xy squared. It's your function. As you can see, your function is a polynomial. It's a polynomial in 2 variables, and if you want to find the limit of the polynomial, direct substitution give you the result. So directly substitute and get your result. So for the solution, so the limit would be equal to substitute. Okay, x to the 5th, x is 5. So that give you 5 to the 5th plus 4x cubed, 5 cubed, times y, which is a -2. Minus 5x, x is 5, times the y squared, which is -2 squared. Okay, so that will give you the result. And you just simplify it and get the result. So that gives you 5 to the 4th. Okay, 5 to the 5th. 5, 25, 125, 625. So 5 times 625. It's going to be 5 times 525, 12. I think that's the one. Check it with your calculator as well. Okay, 5 to the 4th. So the next one is here, 5 cubed. 5 cubed would be 125. 2 times 125 would be 250. 250 times 4 would be 1,000. So that gives a negative 1,000. And over here, a negative 2 squared would be 4. 4 times 25, that gives you 100. Okay, so just usual practice. So it's going to be 4 times 25, which is 100. And over here, this is it, 5 cubed 125. Then 2 times 125, 250, 4 times 250, 1,000. So we simplify it. So this is going to be something like 2,125 minus 100. And the result is going to be 5,202. I think that's one. So that gives you the limit of the function. Okay, that's a straightforward. That's the warm-up. So if it's going to be polynomial, nothing to worry. This is just to remind you, but the one that we're going to have for this group, the one that will have something different, you will see it in a minute. Any question? Second one, again, ordinary function. You want to find the limit of this x squared plus 2xy. Okay, 2xy minus 3y squared divided by x squared plus 9y squared. And this is where x comma y goes to 3 and negative 1. That's it. Again, rational function, you find the limit of the top divided by limit of the bottom. The top and the bottom are polynomials. So substitute again. Okay, direct substitution give you the result, solution. So this is going to be equal to, you substitute those numbers, x equal to 3, y equal to the negative 1. So that gives you 3 squared plus 2 times 3 times negative 1 minus 3y squared 3 times negative 1 squared. Divided by x squared, which is 3 squared. Plus 9y squared negative 1 squared. Okay, directly substitute. So simplify it. So it's going to be equal to, the top 3 squared would be 9. Positive negative would be negative 2 times 3, 6. Negative 1 squared would be positive 1, so that gives me negative 3 again. On the bottom 3 squared would be 9, and negative 1 squared 1, 9. So the top 6 minus 9 would be 0, or 9 minus 9. The bottom one is 18. You know that 0 divided by 18 would be 0. So again, straightforward, nothing to worry. Any question? So, pick one of them when, you put them all together. That was part B. Part C, trigonometric function, but a straightforward one, okay? So checking part C. In part C, you want to find the limit of this function, limit of x comma y. This time goes to the pi half and 0. Pi half and 0, the function is sine x times it by cosine y divided by x. This is it. Again, trigonometric function that give you direct substitution type. Replace x by the pi half and the y by 0, get the result. Okay, so this is going to be equal to the top sine of x would be sine of pi half. Okay, that's 1 times the cosine of 0. And the bottom one is pi half. Sine of pi half is 1, and the cosine of 0 is 1. So that gives you 1 times 1. And the bottom pi half. So it's going to be 1 over pi half. Use the reciprocal 2 pi to find an answer. Okay, you don't have, you can use your calculator to get the numerical value, but it's fine. It's fine to get the 2/pi as the final answer. Okay, so this is going to be the case. Any question? So again, they're all ordinary. In this first group, only the next one is different. We did it before, but I just give you the solution again. This is different. The only one that's going to be different, just remind you again, see the part D. The part D, you want to find this limit. Limit of, okay, this is x comma y goes to 2 and 1. 2 and 1, but the function is going to be this one. Just checking it, yes. The function is, on the top you get x minus y minus 1, and down the bottom you get the square root of x minus y, then minus 1. This is a very famous one, okay? One of the problem in your book, and we did a similar one on the, when we did the lecture. Now, if you substitute, that would be interesting. Your x equal to 2, so that will be 2, y is 1. So this is the top. If you substitute for the bottom one, x equal to 2, y equal to 1, 2 minus 1. Okay, minus 1. Now the top would be 0. The 2 minus 1 inside the radical, that give a radical 1 minus 1. So it's going to be 0, 1 minus 1. That give you 0, 0. See, that's 1, 0, 0. We talk about it, we check to see what sort of function we have. Okay, since there is a radical expression, you know that. As in calculus 1, you have to get rid of that radical to find the common factor. You multiply the top and the bottom by the conjugate of the radical expression. Okay? And sometimes, if it's going to be polynomial, you factor it to eliminate the common factor. But for this one, you have to go back, multiply the top and the bottom by the conjugate of the denominator. That top would disappear, then you'll be able to. Okay? So this is it. So that would be the limit of x comma y going to the 2 and 1. So you write x minus y minus 1 as is, and you're going to multiply by the conjugate of the denominator. Conjugate would be x minus, radical x minus y plus 1. You do the same thing to the bottom. That gives you radical x minus y minus 1. Then you multiply it again by the conjugate, which is a radical x minus y plus 1. You're not going to do anything to the top. You just simplify the bottom, because that's a special product. Okay, it's going to be the square of the first minus the square of the second. So we multiply these two together and these two together. Okay, radical x minus 1 times radical x minus 1 would be x minus 1. So that gives x minus 1 and minus 1. Okay, a square of the first minus the square of the second. As you can see, this is going to be a kind of common factor on the top. So on the top, you have x minus y minus 1 times the radical x minus y plus 1. Now this common factor would eliminate. Of course, this is the limit when x, y goes to 2, 1. Okay, so that common factor will eliminate, and for the leftover, you can just substitute to get your result. Okay, x minus y plus 1. And you substitute it when x comma y goes to 2 and 1. Okay, if you substitute, 2 minus 1 would be radical 1, so the result would be 2. You see, it's going to be the square root of 2 minus 1 plus 1. It's going to be 1 plus 1, which is equal to 2. Okay, for first group, be aware of this type of problems. And if you get a 0, 0, if there is no radical, probably you may be able to simplify it. But if there is going to be a radical one, this is the way you're going to simplify. And you know that there are going to be some other types that we're going to take care of it in a minute. And this is, okay, kind of algebraic expression side for the algebraic. Okay, so that's first group. Any question? Now, the challenging one is the second group. The second group is the cases that you're going to get the 0, 0, then you are not going to be able to find the common factor or using these type of methods. Then you have to prove it, okay? You have to find it. Let me give you one technique for these. Okay, so I'm going to remind you, it's very popular type. So these are the one. Second group, we want to show that these limits are all equal to 0. Okay, it does exist and they are equal to 0. We may ask you to find it. Okay, the way we do it, we group a couple of them together and we ask you. Remember, the thing that you have to consider for this is we are going to use a kind of a squeeze theorem to take care of it. We have to find a bond, a restriction for this group to simplify it. So all of them would contain this kind of term. Look at this one. Y squared on the top, x squared plus y squared on the bottom. We get these quotient. See, you identify this part. See y squared over x squared plus y squared. Denominator is higher than the top. So this fraction is always less than 1. So this quotient, you see that left over is going to be less than equal to 1. So this can be shrink, if you like, into the 2x. And the 2x when x goes to 0 is 0. Done. Okay, but you have to write the details. We can always check for this. Second one is the same. Look at this. That was y squared over x squared plus y squared. Now look at this one. X squared on the top, x squared plus y squared on the bottom. So we are going to take this one out. If you take this one out, the leftover is y. So when x and the y goes to 0, automatically we'll go to the 0 and be done. Next one, same thing. You have x squared, y squared on the top. You have two choices. Again, in this case, you just pick one of them. Then the leftover is going to be easy to handle. The tricky one is the last one. Because you have y squared over x to the 4th plus y to the 4th. This is also bonded, but you have to use it's not going to be bonded by 1. So I show you that how we're going to take care of that last part. So this is the idea of these type of problems. So let's take them one by one and explain it why the limits would be zero. Okay, very popular techniques. If you cannot see these quotient that I talk about it, the limit of this function does not exist. And you know that you're going to pick two different directions to get two different numbers and you reject it right away. Okay, so if there's going to be a possibility that this limit would exist, you need that, okay, that factor, that bounded factor. Close that, check. Number 4. See, this is number 4, part 1. And the part 1, the limit is the limit of 2x y squared divided by x squared plus y squared, then x comma y goes to 0, 0. Okay, you want to prove this is equal to the 0. So we estimate it. The difference between 2x. Okay, you have to estimate the difference between function 2xy squared over x squared plus y squared and the 0. You have to prove that this is going to 0, if you like, okay, to get the definition. So as we talk about it, the 0, we drop the 0, use the absolute value on the top and the bottom. The bottom is positive, you don't need the absolute value. So this is going to be like, let's do it. Let's do this one. This is going to be 2x. Take that part out, you see as a factor, it's going to be y squared over x squared plus y squared. That's the key. If you have this one, you can do it. If you don't have it, this limit does not exist. Now, as we talk about it, this portion is less than equal to 1. So this means this is going to be equal to what? Let's write it down in 2 steps. It's going to be the absolute value of 2x times y squared over x squared plus y squared. Everything is positive. but this is less than equal to 1. So this means the result would be less than what? Less than equal to absolute value of 2x. It's going to be absolute value of 2x times 1, which is the same as, okay, absolute value of, you can pull out the 2, is going to be absolute value of x. Okay, so what you did is, I repeated, 2xy squared over x squared plus y squared minus 0 is less than equal to the 2 times absolute value. Now, you can use the kind of a squeeze theorem type to answer it, we accept it. Then I tell you how you can continue and give us a precise proof. But we accept this one. You see, now you argue. You say that, oh, okay. Now, if x comma y goes to 0, 0, so this means x goes to 0 and y goes to 0. But you need the x here. Okay, then x goes to 0. If x goes to 0, absolute value of x goes to 0. 2 times absolute value of x goes to 0. Okay, so 2 times absolute value of x goes to 0. Now it's like a squeeze theorem. This part goes to 0 and this part is positive, 0, 0. So this is going to be the case, goes to 0, and this would imply that 2x y squared over x squared plus y squared goes to 0. Because the top one goes to 0, so the bottom one would follow. And that's exactly the meaning of the limit of 2x y squared over x squared plus y squared. When x comma y goes to 0, 0, that give you 0. You see, this is one version that you can prove. And if you are going to be a math major, they may question you. They say, oh, you didn't prove it precisely for us. But we accept this one on the test from you, but option 2. Okay, that's going to be option 2. Option 2 is to be more precise, to get that, okay, that norm thing, remember? So option 2 is going to be, you take it from here and you continue. Look at this one. I'm going to elaborate on this and give you. So the option 2 is you have the 2x y squared over x squared plus y squared minus 0. You already proved that this is 2 times absolute value of x. Now the option 2 is, you see absolute value of x is what? This is 2 radical x squared. Because the radical x squared is absolute value of x. Now, 2 times radical x squared is going to be less than 2 times radical x squared plus y squared. You see, you have the x squared, you add the y squared to it. Okay? But you know that this is what? Radical x squared plus y squared is the distance of a point to the origin. Or it's a norm. Norm of the vector x and y. Remember? That give x squared plus y squared. So this would be what? This would be the norm. So you have this 2xy squared over x squared plus y squared minus 0, absolute value is less than 2 times the norm of x comma y minus 0, 0. See the distance from the origin. Now this is nicely proved for you that you can go with the epsilon delta notation that we talked about the other day, or now you can say that if or whenever if x comma y goes to 0, 0, you see the second part goes to 0, 0 right away, then 2x y squared over x squared plus y squared goes to 0 also. And that's exactly the definition of the fact that the limit of 2xy squared over x squared plus y squared is 0 when x comma y goes to 0, 0. And then you that. You see, knowing the second part would be an advantage for you to get a better understanding And, okay, if you're going to be a math major, you have to do this type of proof all the time. But if you can relate them together, you see the key relationship is this one that we create here. If we can relate it together and just then tell us that a kind of a squeeze theorem type, we accept it for the test. But it's just two more steps, you see, two more steps that you will take. So all of these are because of that quantity that you have, which is less than or equal to 1. Okay, so all of them can be done quickly, so we take it. Any question? So the rest are the same, just the last one is different. Are you ready? Let's quickly give you all of them. So we have them because we're going to use them for the next test as well, and then we are not going to review it anymore. So the part B is similar, but the top is a little bit different. Okay, you have the limit of x squared y over x squared plus y squared. You want to prove that this is 0. Again, look at this quantity. You see, that would help you. You have x squared over x squared plus y squared. Again, you have a fraction whose denominator is bigger than the top, so it's less than 1. Less than 1 means forget it. What you have, y. So when x and the y goes to 0, y goes to 0 automatically, and you get the result right, okay? So this is going to be the solution. Again, you estimate it. You say x squared over y, and this is x squared plus y squared minus 0 is the same as. You rewrite this one. You see, pull out the x squared plus y squared, then times y. So it's going to be absolute value of the first one, which is positive. You don't need any absolute value. And times it by the absolute value of the second one now. Question? This quantity, you see this one? This is less than or equal to 1. So this means your result is less than or equal to the absolute value of 1. You can take it from here or just continue with the one that I did. Option 2. Okay, if you want to take it from here, you just explain it. You say, oh, now if x comma y goes to 0, then y goes to 0. So absolute value of y goes to 0, like the squeeze theorem. Then x squared y over x squared plus y squared goes to 0. So I did prove that the limit of x squared y over x squared plus y squared when x comma y goes to 0, 0 is 0. I knew that. Any question? We accept it, but you know, if you like to go to the option 2, continue, you start with the fact that, okay, I explain this one too for you because this is y. So the option is going to be, the option is you take it from here, you see, x squared y, x squared plus y squared minus 0 is less than or equal to the absolute value of y. But absolute value of y would be radical y squared this time. But radical y squared would be less than radical x squared plus y squared. And that's exactly the norm. Okay, so that would be the norm of x comma y minus 0, 0. And that, you know, that will give you the result right away. It's like the epsilon delta notation. So that's clear now that if x comma y goes to 0, 0, then the right side will be 0. Then you get the, okay, you get the absolute value of x squared y over x squared plus y squared minus 0. Okay, I'm sorry, this means this goes to 0 too. Okay, so you got it. The limit of x squared y over x squared plus y squared, x comma y goes to 0, 0, would be 0. We're done. And that would be enough. See, if you estimate it, that is going to be the same thing. Okay, so look for that quantity that we talked about. Any question? The next one is a little bit different, but it's just the same thing. Check that one too. Part C. Part C, you want to prove this one. Limit of x squared y squared over x squared plus y squared when x comma y goes to 0, 0 is 0. Again, easy, because you can take this or the other. See, look at this one. This is less than 1. So if you shrink it, you're just talking about limit of x squared. When x goes to 0, limit of x squared would be 0. Done. Okay, so this is the way we talk about it. Solution. Solution is going to be, this is x squared y squared over x squared plus y squared. You want to estimate it, make it 0. Again, it's you don't need the absolute value at all in this case. So it's going to be x squared y squared over x squared plus y squared. You don't need the absolute value. All of them are positive. See about the second part. Again, this is less than or equal to 1. So your expression would be less than or equal to the x squared. So you can compare it with the x squared. Again, when you see this is it, if x comma y goes to 0, 0, then x goes to 0. You see, when x goes to 0, so x squared goes to 0, and therefore, okay, therefore, x squared y squared over x squared y squared goes to 0, 2. And then you're done. We can go with option 2 again, x squared less than x squared plus y squared, and take it from there. And that would be the same thing. Okay, that would be part C. Any question? Part D is a little bit different. You have to create something yourself. Okay, they are very standard. There are not going to be many of these. I just put all the possibilities here for you. Okay, let's see what is special about part D to finish it. Let me give you one straightforward one. Let's take the D. You see, part D is this. The limit of, you see the part D, this is the part D that we have. You see, in the case of the part D, you have x cubed y squared over x to the 4 plus y to the 4. Your estimate is going to be a little bit more algebra involved to be able to do it. Okay, so let's see how we're going to do it. So we have x cubed y squared over x to the 4th plus y to the 4th. Okay, when x comma y goes to 0, 0. You want to prove this is 0. You see, that bounded portion, you have to make it yourself now. That y squared over x to the 4 plus y to the 4 is going to be your leftover. If you want to work with the x cube, you see the previous one, we get x squared plus y squared. You have to do a little bit of algebra to find that estimate. You see, look at this, because you need x to the 4 plus y to the 4. You can create it yourself. Look at this one. Look at this. Note that Look at this expression to get it. Okay, I'm going to make that x to the fourth plus y to the fourth. Look at this. You see, I start with the x squared minus y squared. You see, this is always greater than or equal to the 0 because of the square. Now, square it. If you square it, what's going to be the result? It's going to be a square of the first, x to the fourth, minus 2 times 2, minus 2 times first times second, plus the square of the second one, y to the fourth, greater than or equal to the 0. Get this? Remember what you want? You want to get that estimate for x to the fourth. So I'm going to keep the x to the fourth plus y to the fourth here. I move everything else to the other side. That gives me 2x squared, y squared. Look at what you have here. Look at this one. I have y squared, x to the fourth plus y to the fourth. So what I'm going to do is I'm going to divide this by x to the fourth plus y to the fourth to estimate it here. So that gives me 2x squared, y squared, divided by x to the fourth plus y to the fourth is less than or equal to 1. And if you don't like this 2, divide by 2. So that gives you x squared, y squared, over x to the fourth plus y to the fourth is less than or equal to the half. So that's the estimate that we're going to use this time. Again, these are going to be good, we've got to be math major. You want to prove things. Now go back, what you have? You have x cubed y squared. I write this one as x. I pull out one x, the leftover will be x squared y squared, and this is exactly what we need. Look at this one. Now we are going to estimate. We estimate this difference, x cubed y squared over x to the fourth plus y to the fourth minus 0. Write it down as absolute value. Drop the 0 and change this one into this format. You see, x times the leftover. What's going to be the leftover? The top would be x squared, y squared. The bottom one would be x to the fourth, y to the fourth. Look at this. What is the inside one? See, it's going to be equal to the absolute value of x. Second part, you don't need any absolute value. X squared, y squared, x to the fourth plus y to the fourth. You see the outside one is less than half, less than equal to the 1/2. So this means x cubed y squared divided by x to the fourth plus y to the fourth is going to be what? It's going to be less than equal to the 1/2 times the absolute value. You see? I show you that you can estimate it with the absolute value of x again. Again, you can go on or just if x comma y goes to 0, 0, then x goes to 0. So 1/2 of the absolute value of x goes to 0. And therefore, by the kind of a squeeze theorem type, the other part, x cubed y squared over x to the fourth plus y to the fourth goes to 0. So you prove that the limit of x cubed y squared over x to the fourth plus y to the fourth, when x and the y goes to 0, 0, is 0. Okay, it's a very unique problem. So, the one that we give you is just one of them, just to make sure that you know the idea. Because you need it for the continuity. Okay, this type of group of problems. So you check. If you can find that restricted part or bounded part, you put it out and you prove the limit is 0. If you can't, okay, if you cannot find it, then you have to prove that the limit does not exist. Okay, I give you a short break. We come back. We have to prove the limit, the case that the limit does not exist, okay? And then the case of the continuity, and we finish it. Okay, it's something like 10 minutes, 15 minutes, we come back. If you have any other questions. Did you get your test back, both of you?
Professor, I actually have a question.
Yes.
In, let me see, I don't know how to show you. So for this step right here at the very beginning where you have x to the fourth plus
Yeah.
y to the fourth is greater than or equal to this, how did we get that it was less than or equal to 1?
You see, you divide both sides by x to the fourth plus y to the fourth.
Okay,
If you divide both sides, this side would be 1,
right.
this side would be answers.
And then this, you just flipped it?
Yeah, I just
Okay.
look at it from this side.
Got
So,
it. Okay.
the other way around.
That was what was confusing me. I got it then.
Because I wanted to be less.
Okay,
That's why I just
you just
think
flipped.
about it in this way.
Okay. that
You
makes
see,
sense.
that's like, you know, it's, see, you just move this one around.
Mhm.
So, because this is going to be less, okay?
Okay,
It's going to be less.
right. Okay, I think
Okay.
I got it. Thank you.
Yeah, they are very classic problems, you know, you cannot find many,
Right,
just very unique.
that makes
You know,
sense.
we can, if you're going to math major, they are going to be things that, you know, exciting.
Right,
But if you're going to be, you know, non-math major, they
Mhm.
accept that squeeze theorem type.
okay,
The right goes to the 0, left goes to 0, so the inside goes 0 with that.
right.
And you have to get this mod.
Yes, oh gosh.
that mod.
Okay. Sounds good then. Thank you.
Okay, so we're going to take the next proof. Next proof we would like to prove that the limit does not exist. Remember we talked about, in order to prove that the limit does not exist, you have to pick two different directions. You know, x and the y goes to 0, 0. It's mostly the limit at the origin. Okay, you can go towards the origin from different direction. We can find two different directions along the x-axis, y-axis, the line y equal to the x, y equal to the x squared, and get two different numbers. In that case, we can say that the limit does not exist, okay? So we have a theorem that we prove, then we're going to use it. So this is it, this is this group. Number 5, we want to prove the limit does not exist. So you pick a different direction. You see the directions are going to be, for example, look at this one. So you may go along the x-axis, means you fix the y, you replace the y by 0. You take the limit when x goes to 0. If you replace y by 0, so that gives you x over x. You simplify that, give you 1. So in that case, the limit would be 1. Then you come back, you pick another direction. Direction along the y-axis. So there is no x. You replace x by 0. So that gives you negative y over y. Then you separate, you get negative 1. So for two different directions, you get two different numbers, so the limit does not exist. Okay, so this is the way we do it. So let's check them one by one. So one of them will be given, this number 5. Number 5, show that the limit, okay, show that the limit does not exist. If it does not exist or it does not exist. Okay, this is it. Number 1, limit of x minus y over x plus y. X comma y goes to 0, 0. So you check it first, then you go for it. We talk about it. So the first option is going to be this one. You take the limit of, you let x goes to 0, and you fix the y. So you substitute for y first, so that gives you x minus 0, x plus 0. So that gives a limit of x over x. There's no y, just x goes to 0. X goes to 0, x is not equal to the 0. So we can simplify the top and the bottom first. It's not 0, 0. It's going to be limit of 1 when x goes to 0. And limit of 1 is 1. So this is in one direction. Any question? So check other direction. Direction of the, okay, of the y-axis. So y goes to 0. You fix the x equal to this. Substitute first. Substitute for x equal to 0. 0 minus y. 0 plus y. So that gives a limit of negative y over y. There's no x. Y goes to 0. You simplify it first. That gives a limit of a negative 1. When y goes to 0, that gives you negative. So two different directions, two different numbers. So this means the limit does not exist. Okay, so the limit of x minus y, x plus y, or just the limit. This is the way I write it down. Does not exist and be done. Okay, that is the first one. Any question? There are kind of 3 possibilities. So you may see 1 or 2 of these. You will see it for the continuity as well. Okay, let's take another one, part B. Part B, this is the limit that you want to investigate. The limit of x y cubed. And we have x squared plus y to the 6. That's a tricky one. So when the powers are different, you got to be careful there a little bit. So you try one direction first. Direction up, you see if you replace x by 0, the top would be 0. The bottom one would be y to the 6. So that gives you 0. If you replace y by 0, the same thing. So it's no good. So just pick one of them. So you have to pick another direction. The direction that gives you a number other than 0. You see, you get a number other than 0 if you can simplify the top and the bottom. You can simplify the top and the bottom if you have a variable with the same power. The same power, you see, like the x squared over x squared, x over x. Just think about it. Look at this one. You see, the bottom, the powers are different. So if you pick y equal to the x, that's not going to be a good one, because that gives you x squared and x to the 6. So you have two choices. You can pick something that raise the power of the x, raise it from 2 to 6. Or you can pick something for the y that reduce this power from 6 to the 6 to the second. Be able to do it. Okay, so it would be easier to do this one. Okay, replace x by a power of y that make it into the 6. Any suggestion? So you have a square over here. Y to what power? Okay, you have the square here. Okay, so you want to get the 6. You already got the 2. So if you divide 6 by 2, that gives you 3. So you better change the x into the y cubed. If you change the x into the y cubed the square will be y to the 6. Then you'll be able to do it. Okay, this is the way you're going to find what power do you need to be able to take care of. Okay, this is the 6. 6 divided by 2, that give you 3. Okay, this is it. Solution. You have to pick one direction along the x or the y to get the 0 first. Okay, so I go with the limit of x goes to 0, fix the y, it's along the x-axis. So if you substitute, you see the top would be 0 because it's going to be x times 0. And the bottom one would be x squared plus 0. So the top would be 0. The bottom one would be x squared, x goes to 0. When x goes to 0, x is not equal to 0. So before taking the limit, this 0 divided by x squared would be 0. Okay, so rewrite it. It's going to be limit of 0 when x goes to 0. Now limit of 0 is 0. It's the way we do it. Okay, make sure they know the order, the logic. Some people over here, they say x goes to 0, it's a 0, 0. Okay, and determine from no, it's not. Because when x goes to 0, you see, x is a non-zero number, you divide first. 0 divided by x squared, before taking the limit is 0. So the limit of 0 is 0. Okay, so that's the first one. Now the other one. We need a number. That's why you have to match the power of the x and the y down the denominator. So as we talk about it, we go with the y goes to 0, but we replace the x by y cubed to raise the power of the x. Now substitute the top x, y cubed. You see y cubed times y cubed times y cubed. The bottom one, y cubed is squared plus y to the 6. Simplify first. It's going to be limit up. The top y cubed times y cubed will be y to the 6. And this is going to be y to the 6 plus y to the 6. Y goes to 0. Okay, so that's going to be limit up y to the 6 to y to the 6. So you do the algebra first, then check the limits. Now y goes to 0, there's not 0, so simplify the top and the bottom. Y to the 6 out. So that gives you limit of 1/2 when y goes to 0, and that will be 1. You see, that's it. In two different directions, you get two different numbers. So the limit does not exist. Okay? So the limit are, this is the kind of different one or the tricky one. The rest are, it can be done right away. 0, 0 is going to be equal to, does not exist. Okay, any question? So you have one more. This case, see what's special about the next one. Are you ready? Getting the last one of this group, part C. See what we need for this. Part C, you want to prove this limit does not exist. Limit R. On the top, you have x cubed y divided by x to the 4th plus y to the 4th. You see the power are the same. X comma y goes to 0, 0. Check this one. Again, you go with one direction, okay, along the x or the y. It doesn't matter. If we replace x by 0, the top would be 0, so the limit is 0. If you go back and replace only y by 0, that gives 0 again. So it's no good, because in both directions you get the same number. So you have to pick the third direction to get different numbers. You look at the powers already the same. Since the power are already the same, so you don't need any extra power. You are going to go along the line y equal to the x. Okay, the first power. The previous problem, the powers was different. That's why we pick, x equal to the y cubed. So in this case, the powers are the same, x to the 4th and y to the 4th. So just pick one, y equal to the x or x equal to the, okay? So you can see the difference on the, you're going to pick those limits. Okay, that's it. So pick the first one. Let's say x goes to 0 and fix the y. So that's it. It's going to be x cubed. I write it down so you know what's going on. X cubed times 0, and this is going to be x to the 4th plus 0. So the top would be 0. 0 over x to the 4th, x goes to 0. Before taking the limit, this is already 0. So that gives you 0 in this direction. Any question? Again, you see x goes to 0, x is not equal to the 0, so that the fraction is already 0. Now the second one, as we talk about it, it must be limit R. X goes to 0, but y equal to x. We don't need any extra power, because we already got x to the 4th and the y to the 4th. Go back, substitute. So that gives you x cubed times y. What is y? X. X to the 4th plus y to the 4th. What is y? X. X to the 4th. Simplify. So that gives you equal to the top, x to the 4th. The bottom one, 2x to the 4th. X goes to 0. Simplify. X to the 4th, x to the 4th out. So that gives you a limit of 1/2. X goes to 0. And limit of 1/2 is 1/2. So two different directions, two different numbers. 0 is not equal to the 1/2. So the limit does not exist. Okay, the limit of x cubed y over x to the 4th plus y to the 4th. Okay, or just the limit. 0, 0 does not exist. But that gives all the possibility, really, when the powers are the same, or when you have to do something to match the powers. So we should be able to, to do this one for us right away. Any question? So that's the limit. proving that the limit exists equal to the 0, or the proving the limit does not exist, or just finding the limit as is. So we combine them together as a couple of questions, and we ask you all of them. Okay, so this is the limit. Now we get to the continuity. Okay, so we give you a function and we ask you to show where the function is continuous. There are going to be two types of functions. And the first one is a function that would give it to you by one equation. But the second one, which is more interesting, are going to be piecewise defined function. See, piecewise defined function. You want to check the continuity of this type of function. The way you are going to do it, you have to, if the function is going to be continuous if you ignore the 0, 0. And then you have to check to see if this is going to be continuous also at 0. For the 0, again, you have two choices. If you see those bonded quotient, like x squared over x squared plus y squared, so you may be able to prove the function is continuous. If you don't see it, check two different directions and reject it. Okay, so that is the idea of the continuity. So it's a one question, two parts. The first part is going to be straightforward. Okay, so let's check the first part first. So it's number 6, continuity. Determine where the function is continuous. Determine where the function is continuous. That is going to be the idea. Okay, the first group is straightforward one. First one is a function of two variables, f of x comma y. And you have 3x squared y minus 4x squared y squared plus 10xy minus 9. What type of function is this one? So if you got the function, you have to find the domain of the function. There is no radical, there is no fraction, so it's a polynomial. And we know that the polynomials are defined everywhere, or they are going to be continuous everywhere. But everywhere where, since the two variables, it's everywhere on R2. So if you see this type of function, it's straightforward, and this is the way we are going to answer the question. You mentioned that f is a polynomial or a polynomial function, and is continuous. Is simply continuous everywhere, continuous on R squared. And with that, it's continuous everywhere. You know, you don't say continuous for all real numbers. Doesn't make sense, because the domain is two-dimensional. The domain is two-dimensional, and the full domain is going to be R squared. So that's type 1. There's no restriction, adding, subtracting, multiplying. So the continuity is there. Okay, this is type 1. Any question? The type 2 is very mild rational function. And we want to know how you write it down. You know, the continuity domain. So that's part B. So the part B is this one, f of x comma y is equal to the xy over x squared minus y squared. This is the second function. You see, this is a rational function. Rational function, the top is polynomial continuous, the bottom one is continuous, and you know that there is a restriction. The restriction would be the fact that the denominator cannot be 0. So we just mentioned that one. So this is it. So for the solution, you can say that f is continuous. F is going to be continuous. Okay, f is going to be continuous for all x comma y such that x squared minus y squared is not going to be 0. Okay, not equal to this. So the domain of the continuity would be this one, or f is continuous. We like, a set notation. It's going to be continuous on, to give us a collection of points, collection of x comma y, such that x squared minus y squared is not equal to the 0. That's it. You can write it down, x squared not equal to the y squared. X is not equal to the positive negative x, but we accept it because we just identified the restriction for us nicely. Read your lecture notes. Remember, we talked about the square root function. There was a couple of nice ones. So you may be given those. So just check those numbers too. And when you pick your assignment, just pick a couple of them. You have quite a lot in your book. Just make sure you know how to write it. Okay, that's the first group. The first group is straightforward. And your job is going to be piecewise defined. Okay? You ready? So the second group. It's going to be one question, 2 parts. The first part is like this. At the second part, the piecewise defined function. You have a couple of them over here. They are very popular, very famous. And a couple of them, you are going to use them when you get differentiation. Part C, this is one of them that's going to be used. F of x comma y. The function is 3xy divided by x squared plus y squared in the condition that xy is not equal to the 0, 0 and is equal to the 0 with the condition that xy is equal to the 0, 0. Okay, that's one. There is a misprint over here. Misprint. Okay, this is going to be 0, 0 as a point. Okay. Yeah. So the way to describe this continuity, first, the domain of this function. You see, if you pick a point, there are 2 possibilities. The point is going to be 0, 0 or otherwise. So this function is defined everywhere on R2. So the first thing to check the domain, solution domain is R2. And function is continuous, and f is continuous. F is continuous on R2 minus the origin. We don't know about the origin. This is the one that you can take it or you can conclude it right away. Because this means you're just focusing on the top one. In case of the top one, if x and the y is not 0, 0, the denominator never will be 0. So this function will be continuous forever. But you have to check, okay? So what you have to do is the question is going to be is f continuous at 0, 0. This is the one that you have to check. So this means you have to check to see if the limit of f of x, y, when x, y goes to 0, 0, is it equal to the 0? Because the f of 0, 0 is 0. Okay, so that's the question. When x and the y goes to 0, 0, x and the y is not equal to the 0. So this is equivalent to the fact that the limit of 3xy over x squared plus y squared, when x comma y goes to 0, 0, this would be 0. Okay, you can write all this in short form, and this is what will happen. Okay, because when x and the y goes to 0, 0, this means x and the y not equal to 0. Now check. You say, look to see if you can find that bounded factor that I did when I proved those limit 0. You see the bounded factor is x squared over x squared plus y squared, or y squared over x squared plus y squared. You can't see it. So go for it and show that this limit does not exist. To prove this limit does not exist, you have to find two directions. One of the directions are going to be along the x-axis. Put x equal to the 0. The top would be 0 quickly, so that gives you 0. The powers are the same. Remember, when the powers are the same, so you are going to check it along the line and y equal to the x. So that gives you different numbers. The limit does not exist. The function is not going to be continuous. Okay, so this is the way you investigate. If you cannot find that bounded factor like x squared over x squared plus y squared, try to reject it. To reject it, okay, two direction. The first direction is this one. The limit of, okay, x goes to 0, but y is 0. So if you substitute, that gives you 3x times 0. This is going to be x squared plus 0. So the top would be 0. 0 over x squared when x goes to 0. X goes to 0, x is not equal to the 0. So before taking the limit, that quotient is already 0. And the limit of the 0 is 0. So that would be case 1. Any question? So there is no use for the second case. If you put the x equal to 0, you get the same thing. So you have to go to the third direction. Since the powers are the same, the direction would be y equal to the x. If the powers are not going to be the same, okay, so you may go with the y equal to the x squared cube to the 4th to the 5th. So go with limit of x goes to 0, but let y to be equal to the x. Substitute. So that's a 3x, we have a 3x y. So we replace the y by x, 3x times x. And the bottom one is x squared, replace the y by x, that gives x squared again. So that gives you the limit of, the top would be 3x squared. The bottom one, add them together, 2x squared. X goes to 0. X squared and x squared will cancel out. You get 3/2. Okay, go to the limit of the, no, it's the 3/2. At the limit of the 3/2, x goes to 0, which is equal to the 3. You see? Two different directions, two different numbers. So the limit does not exist. So this means the function is not continuous at 0, 0. Okay? So 0 not equal to the 3/2. Okay, so this means, just for your information, you can conclude right away, you accept that. Okay, this means the limit of the function at 0, 0 does not exist. So f is not continuous. F is not continuous. Okay, it's not going to be continuous at 0, 0. So the conclusion, just the first one that we create. You see, look at this one. This function is continuous everywhere except at the origin. If you can prove that it's continuous also at 0, 0, you say it's continuous on R2. So the conclusion is that f is continuous. F is going to be continuous on R2 minus the point 0, 0. Minus the origin. Okay, it's very, very nice technique. This function is very important. You will see later on. When we talk about the partial derivatives, we bring this one up, this one back. It's a There is one counter example that I know that this is going to be represented. So that's why we prove it now and then we keep it for future. Okay, so this is the way you guess that the function is not continuous at the 0, 0. Any question? It's case one. Let's take a couple of cases. So you get the experience that will be good for you. So as soon as you see it, you can identify it. The next one is this one, x squared y squared, x squared plus y squared. Look at the function. Again, the domain is r squared. So you have to check the continuity at 0, 0. So we check to see if we have that bounded factors. You see, you have that one bounded factor. Look at this one, y squared over x squared plus y squared, or x squared over x squared plus y squared. So automatically you guess that this function is continuous everywhere. This is the way we do it in future, okay? You have a look and you get it. But for the time being, you have to prove it for us. Okay, any question? This is the way you find out, okay? X squared plus y squared. Remember, it's less than 1. Or y squared over x squared plus y squared. So we check this. This is going to be our part D. There are special cases, and you can easily identify them. This is it. This is going to be part D. So the part D, the function is this one. F of x comma y is equal to, the first part is x squared y squared divided by x squared plus y squared. Okay, with the condition that x comma y is not equal to the 0, 0. And the function is 0 at the origin. At the origin. That's it. We want to check to see if this function is continuous. Again, the domain is r squared. To start with, it's continuous if you disregard the 0, so you have to explain it. Okay, solution. You declare that the domain is r squared, and the function f is continuous. Okay, it's going to be continuous on R2 minus the origin. Okay, because if you exclude the 0, you have nothing to worry about. Because in that case, the denominator, okay, the denominator is not going to be 0. So the question is going to be, how about 0, 0? Is, these are just your for information, you can do it right away. Is f continuous at 0, 0? So this basically means, is the limit of function, limit of f of x comma y, x comma y goes to 0, 0, which is the same as the limit of x squared y squared, okay, over x squared plus y squared. When x comma y goes to 0, 0, is it equal to the 0? If it's going to be 0, the answer is yes. If it's not going to be 0, the answer would be no. Check for the bounded component. You see, bounded component. This is less than 1. Answer would be yes right away. But you know, you have to write it down. But in future, we accept it. We say, oh, note that. Have something for you. You estimate it. Note that x squared y squared over x squared plus y squared minus 0. Remember, you have to estimate. You drop the 0, everything is positive, you don't need the absolute value. You see, this is it. X squared y squared, x squared plus y squared, You don't need the absolute value, and you can rewrite it as x squared times y squared over x squared plus y squared. This quantity is less than or equal to 1. Okay, because the bottom one is higher than the top. It's like, like 4/5, 1/2, 2/10. So this means x squared y squared over x squared plus y squared is going to be less than or equal to the x squared. That's it. You can go with the, those options that we talk about it, but you can conclude that and say, oh, now if x comma y goes to 0, 0, okay, then x goes to 0, so x squared goes to 0. And kind of a squeeze theorem type, therefore, x squared y squared over x squared plus y squared goes to 0. It's like the squeeze theorem because this is bigger than 0. This is going to be 0, 0 on both sides. So that's it. So this means the limit of x squared y squared over x squared plus y squared, x comma y goes to 0, 0 is 0. So this means the function is also continuous. So f is also continuous at the origin. Also continuous, okay, at 0, 0. With the conclusion, nice function is continuous everywhere. F is continuous. Okay, f is continuous on R2 and with. Okay, so two possibilities. If you cannot pull out those bonded factor, so you reject it by introducing two different directions. If you can't find it quickly in future, if you have a look to say, oh, it's continuous, you don't need to prove anything for us as soon as you see it. But for this time, you have to prove it for us. Okay. So that gives you two possibilities that may happen. We have a couple of them, but they're going to be all the same. Any question? So expect one type, the first one or the second one. This next one is interesting. Okay, part E. It's easy but interesting. You haven't seen it. F of x, y is going to be this one. You have x, y, and this is x squared plus xy plus y squared. It's the case when x and the y is not equal to the 0, 0 again, and it's 0 when x comma y is equal to the 0. And check this one. Okay, again, the same thing. If x and the y is not 0, 0, nice function. Okay, the numerator won't be 0, so this function is going to be continuous. You have to check the 0, 0. So check to see what it's going to be, how I'm going to guess. You want to find the limit, look at this one. You don't see that bonded, okay, that bonded factor. So there is a possibility that you can reject it. So to reject it, you have to pick direction. So you pick the direction, you see if you put x equal to the 0, this is going to be 0. And you get a y squared here, so it's going to be 0. Okay. Then if you pick a y 0, you get 0 again. So you need another direction. The powers are the same. X squared, y squared. So if you check the direction along the y equal to the x, that give you a fixed number, and then you're done. Okay, this is the way we do it quickly. You have to explain it. Okay, so that's it. The explanation is going to be the following. Again, domain is R2. KD is going to R2 and F is continuous. Okay, F is continuous on R2 minus 0, 0. So that would be your first interpretation. What's the question? Question is what would happen at 0? Is F continuous at 0, 0, which is the same as, is this limit exist? Limit of, it's going to be limit of f of x comma y, x comma y goes to 0, 0, which is the same as the limit of x comma y goes to 0, 0. And the quotient is this one, x times y, x squared plus xy plus y squared is this one equal to this one. Again, you can do all of them at the same time. Okay. So this is going to be the case. As we talk about it, we think that this limit does not exist. So we have to pick the direction. First direction is clear, you know, we put the y equal to 0 to prove it. Okay, so first direction, x goes to 0, fix the y. That should give you the 0, which is the case. It's going to be x times 0. You get the x squared here, and these are going to be 0, 0. Okay, so we arrive at the fact that it's going to be limit of the 0 on the top, x squared on the bottom. X goes to 0. Again, before taking the limit, that fraction is 0. Okay, so it's equal to the limit of 0. And x goes to 0, so that would be 0. That's the case 1. Okay, so you need a non-zero number. So it's no good to let x equal to 0. We get the same one. Again, the powers are the same. So take it along the line y equal to the x. Okay, so limit of x goes to 0, and you let the y to be equal to the x. Okay, go back, substitute. We have xy here, it's going to be x, and the y is x. Down the bottom, we get x squared plus xy, xx, and plus x squared. Simplify. The top would be x squared. It's going to be x squared plus x squared plus x squared. X goes to 0. Simplify, then take the limit. Limit of x squared on the top, 3x squared on the bottom. X goes to 0. Okay, drop the x squared. So that gives you 1/3, limit of 1/3. X goes to 0, which is 1/3. So two different numbers. So this means the function is not continuous at 0, 0. Okay, so f is, because the limit does not exist, f is not continuous. Not continuous at 0, 0. So the conclusion is continuous on R2 minus 0, 0. So the conclusion, f is continuous only continuous on R2 minus 0, 0. We cannot, you know, we were not able to prove the continuity at 0. Okay, so it's a double bonus. You're just checking those limits again, get good experience. Okay, be quick to be able to do it. Okay. So this and next one, we already done. You know, we just check it with the limits. So it's good to see it with the continuity too. X cubed y squared, x to the 4 plus y to the 4. It's the one that we proved that the limit does exist. So let's check it in the concept, okay, of the continuity. Any question? Are you done? So going to the part F, you have all the possibilities on this review. There is nothing else really they can do. They have to give you something very similar. Part F, this is the function f of x comma y is equal to, so you have x cubed y squared divided by x to the 4th plus y to the 4. Again, when x comma y is not 0, 0, and it's 0, and x comma y is 0, 0. That's it. Again, domain is going to be r squared. Okay, R2. The function is already continuous when x and the y are 0, 0. And in a term of the 0, 0, you see there was very special function. Remember this one was special that we prove it. We pull out the x squared from here. The top would be x squared y squared. That's x to the 4th plus y to the 4th. This is the one that I create that inequality for you. But so you have to repeat it again over here. Okay, so this is going to be the solution. Say that the domain is r squared and f is continuous. F is going to be continuous on on r squared minus the origin. So again, you are going to check to see if the f is going to be continuous. Okay, is f continuous? Just for your information. And do it right away. Continuous at 0, 0. So it's the same as proving that the limit. Okay, proving this limit of x cubed y squared over x to the 4th plus y to the 4 when x comma y goes to 0, 0 is 0. You have to prove this one. And we did it, we estimated. You see, this is, I just remind you the way I estimated. This is the way we did it. See that the x cubed of y squared over x to the 4th plus y to the 4, absolute value minus 0. So what we did, the top, we just break it into x and x squared y squared over x to the 4th plus y to the 4. Okay, so this is going to be now absolute value of x. The leftover are all positive, x squared y squared, x to the 4th plus y to the 4th. Remember, I proved for you that you can use it anytime you like. I proved that this is less than 1/2. Less than equal to the 1/2. Remember the one that I create, x squared minus y squared, whole square positive. You see, you can use this one anytime you like because I've already proved it for you. This is the one that we did. Okay, this is it. No, that's it. Which one was it? I proved it. That was yeah, this is the one that I proved for you. Okay, remember, we start with the x squared minus y squared bigger than or equal to 0, and we create this. So we can use it anytime you like. Okay, So we're getting back here. So this is less than or equal to the 1/2. So this means the absolute value of x squared, sorry, x cubed y squared over x to the 4th plus y to the 4th minus 0. Now it's going to be less than or equal to 1/2 of the absolute value of x. Now we can say that if x goes to 0, you see if x comma y goes to 0, 0, then x goes to 0. So 1/2 of the absolute value of x goes to 0, and just a square student type. Therefore, the quotient x cubed y squared over x to the 4th plus y to the 4th would also go to 0. Okay, so we proved that the limit of x cubed y squared over x to the 4th plus y to the 4th when x and y goes to 0, 0 is equal to the 0, which is the same as f of 0. So f is also continuous. F is also continuous. Okay, it's going to be continuous on R2. Sorry, continuous at 0, 0. So the conclusion is that f is continuous on R2. F is continuous everywhere on R2. See, we take it as a limit in the previous problem. Now we can put it over here. Okay, so we have all the different combinations. The only thing is missing is the one function of 3 variables. You better check your check your lecture notes. Probably we get one of them on the test. I know, but we can check it later. Okay, so we have one more to just finish it, and that would be very easy. And last one. It's very much like the we already got one. See, it's like the part D. Okay, with the part D, everything is the same. I think it's from your book that I put it over here. Because you can pull out the 4. In part D, we prove that the function is continuous. Because you have that quantity of, you see, y squared over x squared plus y squared. I don't know why maybe that's from your book that I'll write it down twice. Okay, but it's going to be continuous. I just explain it. Probably this is going to be this is the case. I don't know. I never checked, but it's easy problem. So there is a reason that I put it over here. Maybe this is in your book, okay? But check it. But as is, nothing to worry about. The function is f of x, y is equal to, the top is 4x squared, y squared over x squared plus y squared when x comma y is not 0, 0. And the bottom one is 0. So as you can see, you have 2 factors. You see, this is the factor that you have. So quickly, that gives you the idea that the limit of the function at 0 is 0, and then it's continuous, whatever. Okay, so let's finish it. If it's going to be the problem, again, you say that D is R2 domain and F is continuous. Okay, it's going to be continuous on R2 minus 0. Now we check the limit. We check to see if the limit are limit of 4x squared y squared over x squared plus y squared. When x comma y goes to 0, 0 is 0. And the answer is yes, because of that estimate that we have. Okay, so this is going to be the case. Note that you can rewrite it. You see 4x squared y squared over x squared plus y squared. You pull out that 4x squared, the leftover is y squared over x squared plus y squared. But we did this one several times, that this is less than or equal to 1. So we have the squeezed inequality. So this means 4x squared y squared divided by x squared plus y squared minus 0 is going to be less than or equal to the 4x squared. So you connect them together. When x goes to 0, this would be 0. So be done. So if x comma y goes to 0, 0, then 4x squared goes to 0. And so 4x squared y squared over x squared plus y squared goes to 0 too. Okay, so f is also continuous. F is also continuous at 0. The conclusion would be conclusion, f is continuous forever. F is continuous, okay, on R2. So it's like, you know, like the okay, so that should give you a good idea of how we check these functions. Okay, that will be important for us, okay, because when we get differentiability, after your quiz, we start talking about derivative. Then we can connect with this notion of the continuity. Okay, that's it. So your quiz would be up to the end of section is 13.1 and 13.2. Definition, no partial derivatives. So I post your quiz. I try to post it by Friday or maybe tomorrow night. So that give you time, to start working on it. And there's a set of assignments that you have to, submit by Monday. So I check it and I post it for you this. After the quiz, we go with the differentiation. The idea for differentiation would be, it's easy. There are going to be several types of derivative for the function of two variables. So that will take us to the test two. Okay, that's it. Any question? Well, I will post this one, so in case somebody